Before we get into it, I found two other ways to convert decimal numbers into binary. The first one's called convenient addition, and you will need your powers of 2 up here, 1, 2, 4, 8, 16, 32, 64, so on and so forth. So let's take a number like 55 as a decimal. So 55 with a little 10, that's terrible. And so we've got to convert that decimal number, 55, we've got to convert that into binary. So in this method, what you're doing is you're looking for numbers that you can add together to give you 55. So you automatically know that 256, 128, 64 aren't going to work, right? Because you can't add those together to get 55. 64 is higher than 55. So if we start with 32, we'll put a 1, because 32 goes into 55. 16 plus 32 gives me 48. So let's go ahead and add that. 48 plus 8 is 56. So we can't use the 8 because that's too high. 48 plus 4 is 52. 52 plus 2 is 54. And 54 plus 1 is 55. So 110111 is the binary number for 55. Let's do our division method just to check. So 55 divided by 2, not 3, should be 47. Not 47, 27. And so 27 with a remainder of 1. So if I bring the 27 down, 27 divided by 2 is 13, remainder of 1. 13 divided by 2 is 6, remainder of 1. 6 divided by 2 is 3, remainder of 0. 3 divided by 2 is 1, remainder of 1. And 1 divided by 2 is 0, remainder of 1. And remember, when you do the divide by 2 method, you read from the bottom up. So 110111. 110111. So that's pretty cool. I did put some video tutorials up on how to do this method. So let's move on to the second method, which is greater than, less than subtraction. This one's a little more confusing, but I like to show it because it's kind of cool. So we'll also need those numbers. Let's go ahead and put that up there. 256, 128, 64, 32, 16, 8, 4, 2, and 1. You need to get in the habit of just memorizing these numbers. It'll make it much, much easier for you. Let's do one that we already know the answer to, that 55. Right? We know that that needs to be the 110111. So this will kind of help make sure we're going in the right direction. So now what we're looking at is we got this number 55. And the general rule for this method is if the number is greater than or equal to, then you write a 1, then subtract, then repeat. And I'll show you what I mean by that in a second. If the number is less than, then you put a 0 and then repeat. All right, so let me add my equals to line here. So let's start. 55. Is 55 greater than or equal to 256? And actually, you don't have to do that. You can go through, and all the numbers that are bigger than 55 we won't use. So we could technically start at 32, but it doesn't hurt to go to the steps. So 55 is less than 256. So we write a 0, then repeat. 55 is less than 128. So we write a 0, then repeat. 55 is less than 64. We write a 0, then repeat. 55 is greater than 32. So we write a 1 and now subtract. 55 minus 32 is 23. So now we repeat. 23 is greater than 16. So we write a 1 and subtract. 23 minus 16 is 7. Equals 7. 7 is less than 8, so we write a 0, then repeat. 7 is greater than 4, so we write a 1. 7 minus 4 equals, that looks like a 9, that's supposed to be a 4. equals 3. Then we repeat. 3 is greater than 2, so we write a 1. Subtract and repeat. 3 minus 2 is 1. 1 is greater than or equal to 1, so we write a 1, and then we're done. The answer is 110111, which was exactly what we got the other two methods. So either way, like I said, I'm handing you a sheet that shows you how to has the binary in there. I'll give that to you tomorrow. So really, even if you don't know any of the methods, you'll still be fine. So on to the purpose of today. We are going to draw chips, the computer chips. Remember I said when you were doing the tables yesterday? So far the information you should need is the name. So we'll go and. You'll need to know the expression, A times B equals Y or Q or whatever. You'll need to know the symbol. This was this bullet looking thing. My son watches the most crazy things. So there's A and B. And so you need the name, the expression, the symbol, and then we needed the truth table. If you remember, the truth table was A, B, Y, and then it was 0, 0, 0, 1, 1, 0, 1, 1. In the AND gate, it was off, 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 and finally on. So this is all the information you need, and I told you yesterday to leave space to make a chip. And so we're going to do that. So the chips are going to be rectangular, and we're going to build these. I'm going to build this one, and then I'm going to show, and then you all will build the rest of them on your own. And we do not want that to be that dark, so let's paint it in. All right, so here we have this rectangular chip. Now what you want to look for is all the chips will have this little U, and you need to make sure it has that U because that tells you which way to orient the chip. And sometimes they have a little dot, and that tells you where the first pin is. So most of the chips are going to be 8, 14 pins, some 16 pins. Most of ours are going to be 7. So I can't draw straight lines, but there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now every chip needs to have these 4 things. Some voltage source, some ground source, some inputs, and some outputs. Some chips will have more than that, like a clock signal or a reset, but all of them should have at least these 4. The first one we're going to look at is the 74HC08. That's the type of chip that we use. We're using the 7400 series. And what we're going to do is we're going to draw what's called a pinout diagram. So very simply what you do is you go into Google. So let's pull up Chrome. And inside of Google you type in 74HC08 pinout. And here's what a pinout diagram looks like. So I'm going to pull up one that I think looks good. I want one that tells me the name. So this one says quad 2 input AND gate. Let's go ahead and click that. That name you need to write down. Quad 2 input AND gate. So I'm going to put that right below this. Quad 2 input AND gate. Because that's important. That's what this chip is. What that means is there are 4 AND gates. Each AND gate has 2 inputs. That's what that means. So let's go back and I'll show you what the pinout diagram looks like. This is a pretty good one. This pinout diagram here, the reason I like it is because of, you see the little U here, which tells me which way to orient my chip. You see the voltage on pin 14, the ground on pin 7. You see the shapes. I'd really like it if it told me the inputs and outputs. So let's go this one. That's a very, very nice gate right there. You can see pin 1 through 14 is labeled, and you can see A, B, 0. You know, these will all be a little different. As long as you get the gist, you're going to be fine. let's use this one. And again, I just typed 74HC08 pinout. So you can see they have the pins 1 through 14 labeled. So let's go ahead and in ours, label them 1 through 14. I'm just going to label the highlights 1, 8, oh, I'm sorry, should be 7, 8, and 14. Now you look on this, 14 is where the voltage goes. So that's where the VCC goes. And 7 is where the ground goes. So we will connect pin 14 to our voltage source, or the positive line on our breadboard. We'll plug pin 7 into, or connect it with a wire to the negative line on our breadboard, the ground. Now we need to look at all these other individual pins. And you don't have to draw the shape of the gate in yours. I do because it helps paint a visual picture that they're AND gates. But you can see it has the A input on gate 1, the B input on gate 1, and the output on gate 1. So we need to put those. So this was 1A. Whoa, that's not what I wanted. This was 1A. This was 1B. This was 1Y. And we repeat this. 2A, 2B, 2Y. Now notice on this, when we go around this way, then it goes YAB. So you got to make sure you write that down. So this one's 3Y, this one's 3A, and this one's 3B. Oops, we got to shift them over. 3Y, 3A, 3B, and then we finish it up with 4Y, 4A, 4B. And that's it. That's all you need to know. Like I said, you don't have to draw those shapes. It is nice to know that it makes an AND gate shape, so I could physically draw the little bullet here, you know, the little AND gate bullet, and draw that the output goes there and that the inputs are going there and there. And I could draw 4 of them, one there, one there, one up there, and one up there. But you don't have to do that. The fact that you have it labeled as AND and right over here you have the shape for AND should be common sense. So this is an example of what you're going to do. Your homework assignment is to do basically the rest of them. So I'm going to type them here so you have them. You need to find the 74HC32, 74HC04, the 74HC, actually I already have this all written down. Right here, the 00 and the 10, the 02 and the 86, and the 11. So this is what you need to do. The assignment's on Canvas, but you need to make one of these pinout diagrams for the rest of these gates. And I will quiz you on it tomorrow, so being confused is not an excuse. If you're confused, you need to come see me tomorrow morning. I'll be there at 7:30. It's all you have to do is Google, so I'm going to show you one more time. Go to Google. I'm going to type in 74HC32 pinout. And right here is the pinout. You can see it's called a quad 2-input OR gate. And here it is. 1A, 1B, Q1. Q, and then that's actually wrong notation. Should look like that. And so you've got to find all of these. Here's the one I want. So yeah, 1A, 1B, 1Y, 2A, 2B, 2Y, ground, 3Y, 3A, 3B, 4Y, 4A, 4B, and voltage. So most of them will be the same. And if you want to say, hey, it's the same, then it can just be the same. If you have any questions, please send me a Canvas message.